Okay, welcome Alex and Donald and Kylie and Tina and Terrence and Armando. Thanks for coming. This is the week 7 webinar, and we got two actually big things to talk about today. The first is hypothesis testing. That is the chapter 9, but it's really, hypothesis testing is the rest of the class. We're going to be spending pretty much every chapter for the entire rest of the quarter doing hypothesis testing. There's a little bit of regression analysis, but that even has some hypothesis testing. So today's a big day in that I'm introducing what we're going to be looking at for all of the rest of the entire statistics class. And then the other big thing is, what big thing must you have completed by a week from tomorrow? And hopefully you all know. Yeah, the midterm. So by a week from tomorrow, you must have taken your midterm, and that must be done with a proctor. So it's the first time of 2 times where in this class where you actually required to leave your computer for this class. Although I guess project 1, you had to do a survey, you had to ask people, so that's leaving the computer too. But the proctor is necessary. I'll be talking all about that in the second part of this webinar in terms of how to prepare for the midterm and getting a proctor and all the different things and that you need to do to succeed on this midterm. The midterm is a big part of this class. So you don't want to act lightly on it. You want to make sure that you really get it. So those are the 2 big things we'll be talking about. Before I start, are there any questions that you might have? Any questions at all? Any questions? Okay, if there aren't any questions, let me get going and talk about hypothesis testing. So I'm going to kind of bring it up by looking at an article. So let me show you an article, and this came up. So this is a Quinnipiac poll, and note a couple things. One is this is just a regular article. This is not a peer-reviewed journal or anything like that. So one thing is that this would not be okay to post for this week's discussion assignment. For this week's discussion assignment, you must be posting a peer-reviewed article, and where this is just a regular article instead of peer-reviewed. It's an important one. Let me read at least the first couple words of it, because that's what I want to talk about. It says, a majority of registered voters nationwide say that climate change is an emergency. So what I want to do is I want to say, well, is it really true that a majority of all Americans think that climate change is an emergency? So first thing, does the Quinnipiac know about all Americans? What do y'all think? That's who published this. Do they know about every American? And can say they definitely don't know. Okay, and that's kind of what statistics is all about, is we don't know about all Americans. I know for a fact they did not ask every American this question. I know for a fact because they didn't ask me, and I'm American. So, and my guess is, did any of you get asked? So far in the history of my teaching, I've never had anyone say, yeah, they called me up. Because again, there's a lot of Americans. There's over 300 million of us, and no, they can't get everyone. So what we want to do is we can say, well, we have a little thinking, and that is that we're looking at a majority. The question is, do we have evidence to suggest that a majority of Americans think that climate change is an emergency? Any questions on that? So I'm going to leave this, but I want to jot a few things down. I'm going to write them down. First thing, 56% is what they got out of their survey. And second, if I scroll down, we'll see that the sample size was 1,422. Okay, and that's one of the reasons why I grabbed these kind of articles instead of just some kind of CNN poll, is that they actually give you the sample size in this particular site. So now I'm going to change things around and not read this whole article. Now I want to actually run what's called a hypothesis test. So let me go to a paint screen. And there's an order at which you conduct hypothesis testing. The very first thing you do is you decide on something called the null hypothesis and the alternative hypothesis. So in this case, the null hypothesis, and null hypothesis will always be this, it's kind of the status quo. It's kind of what we're trying to show is not correct. So if it's not a majority, what's the highest percent it could be and still not be a majority? Maybe you can say it or put it in the chat box. Actually, it could be more than 49. Not 30. Yeah, 0.5. And not as percent, but as a proportion at least. So the definition of majority is greater than 50%. And that doesn't necessarily mean 51%. My most favorite example is that it took a majority of the electorates to put me in office, me personally. And I did not get 51% of the votes. I got 50.02% of the votes. It was a very close election when I ran. But I still won by the majority, and they appointed me as a school board member. So just note, majority does not necessarily mean 51. And less than majority doesn't mean 49, it means 50 or less. So the way we write that down in terms of the status quo, if it wasn't a majority, the highest it could be is 50%. So what I'm going to write down is H not. And then this is a yes/no question. Is climate change an emergency or is climate change not an emergency? And when you have a yes/no question, what letter do we use to talk about the main statistic for a yes/no question? What letter? Yeah, P. Notice we use P when it's a yes/no question. And when it's a quantitative question, what letter do we use? And you're not going to be able to type this one in. You can type the word, but not the letter itself. That's a hint. Yeah, it's mu. And that's the Greek letter mu. But in this case, it's a P. And P equals 0.5. Because if it's not a majority, the kind of worst case scenario, or the highest case scenario is exactly 50%. And H stands for hypothesis. So we say H naught, I want to mention something. When we read this, you'll see that it's an H, and it's sub-zero, and then a colon. That's not an equal sign, it's a colon. So anytime I ask you to write down the null hypothesis, you must have that written down, H naught and a colon. So you'll get a point just for writing that, and it's every single time it's exactly the same thing when it's a null hypothesis. Then it won't always be a P, sometimes it'll be a mu, and this week, and then later on we'll have different things. Then you're always going to have an equal if we're in this chapter at least, and then the number is going to be whatever makes sense. Do we need to put H and, it's actually H0, but if I wrote H0, the 0 looks too high, so I actually use an O. But technically it's H sub-0. And I found with a typewriter, with a keyboard, it's easiest to write it this way, because subscripts are really hard on the keyboard, okay, especially with paint. So just let you know. But the British got to it before the Americans did, so we don't use the word 0, we use not, because that's how you say 0 in Britain. If you ever watch any Britain shows that had that. So just let you know, that's how everyone says it. Okay, then we're going to have what's called the alternative hypothesis. And there's a couple ways of writing it. I'm going to write it as H1, and it's usually subscript 1, but I'm going to leave it as H1. Sometimes you'll also see it as HA, A for alternative, or 1 for after 0. So either way, I'm good with it. You should understand, be able to read both of them, and write whichever one you like to write. And then still a colon. And then we're going to still have a P. But now so H naught is if we're wrong. H1 is if we're right. And what the article states is the majority think that climate change is an emergency. So if it's the majority, what do we know about the proportion? What does it mean to say majority? Yeah, greater than 0.5. So I put greater than 0.5. Any questions on that so far? Any questions? Okay, so now the next thing, and the order is really important at which you do things. Always the very first thing you do in hypothesis testing is you decide on the null and alternative hypotheses. Okay, you can't do that later. You can't do that after you look at the data. You're supposed to always do it before you look at the data, before you collect your data. Then the next thing you do in a hypothesis test is you come up with what's called a type 1 error. So a type 1 error, what that means is that we're going to end up making the conclusion that H1 is true when H1 is not true. So a type 1 error in this case means that we're going to conclude that it's greater than 50%, when in fact, it's not greater than 50%. Okay, now think about, let's say you're running for political office. Okay, there's lots of things we can think about. If you're running for a political office and that happened, a type 1 error happened, what issues might happen? Okay, where will things go wrong? Because it's an error. Error means something went wrong. So let me write down. Type 1 error. Repercussions. Not sure about the spelling of that, so sorry if it's wrong. So type 1 error repercussions. Repercussions mean damage done when it happens. Okay, so what are the type 1 error repercussions in this case? Yeah, you lose. So what it probably means is that you're going to say, well, we've done the survey. We've decided that, yes, majority of Americans think climate change is an emergency. So then as a politician, when you're running for office, you're going to like put that as the #1 thing that you're going to say, I'm going to do something about climate change the moment I get into office because it's an emergency. Okay, is that clear? And then what happens is that you are actually wrong about the majority, and most people really don't think of it as an emergency, and they're not going to be interested in voting for you. Okay, they're going to be more interested in voting for the candidate that's saying, well, climate change is no big deal. We don't have to worry about that right now. We can wait on it. Okay, and then you lose because you did your whole campaign based on this and no one really cared. And you'll probably lose the election. So the repercussions is that, and I'm going to think of it in the political way of looking at it, is that you run your campaign based on thinking that climate change, that the majority think climate change is an emergency. But in the end, the majority don't vote for you. That's pretty bad, right? Okay, and that's called a type 1 error repercussion. It means that H naught was true, but you decided that H naught was false. Okay, so you weren't able to show it was majority. You showed it was majority, except that it wasn't. Do you realize that's an error? Okay, so now the next thing you want to do is talk about what's called the type 2 error. Type 1 errors are often called false positives. Have you heard of that before in medicine? Not sure if you've heard that. False positive, I like to think about like a pregnancy test. A false positive means that you take the pregnancy test, says you're pregnant, and you're not. Okay, and there's some bad repercussions on that because you get all excited, you buy the crib, you have all the parties, and then you end up not having a baby. Okay, so that's a false positive, also called type 1 error. Whereas a type 2 error is the exact opposite. Type 2 error is a false negative. So that means that you were not able to find evidence that the majority think that climate change is an emergency. But the majority do think climate change is an emergency. So in that case, what are the repercussions? What bad things will happen to you, let's say in politics? Any thoughts? So what bad things would happen for type 2 repercussion? Type 2 is very different than type 1. Any thoughts? You can talk or type. Yeah, you downplay it. You don't put that as part of your campaign. So you don't include climate change as part of your campaign. When it would have gotten you enough support to win the election. Any questions on that? Okay, and that's a problem too. Okay, they're both bad. In this case, they kind of both have the same, you still lost. That's not always true though. Sometimes they have different outcomes. I mean, in this particular example they do, but other examples of a hypothesis test, they may have different outcomes. But they're always bad. The type 1 error and the type 2 error are never good things. That's why we call them errors. Okay, because what ends up happening is based on your study, you don't end up with the truth. And that's bad because you're always hoping for the truth. Yeah, it could be people die, it could be losing money. There's all kinds of different things that can happen. It'll always be bad though. I chose this one because I found this in when I went through news articles, this is the first one I found that was a good article for our example. And I always like to bring, if I can, current events, things that are relevant to what's going on now. All right, any questions so far? Okay, so the next thing we do, again, this is step-by-step. Number 1 is decide a null and alternative hypotheses. Number 2 is think about the type 1 and type 2 error. Number 3 is determine the level of significance. And the level of significance is actually the probability of a type 1 error. And the standard level of significance is 5%. Okay, and that's just standard. It was actually developed, standardized in the 1930s, I believe, by the New York Times. And they were king of news at the time, so everyone went with it, and they've all still gone with it. So that's standard. It doesn't mean you always have to do it, but that is standard, is 5%. So in our class, we're going to either use standard, which is 5%, or we're going to decide to go lower, like 1%, or we're going to go higher, 10%. So those are the 3 choices for our class we'll do, and that covers almost every study that you'll ever see. So the reason why you would go to 1% is if the type 1 error is worse than the type 2 error. The reason why you would go 10% is if the type 2 error is worse than the type 1 error. So in this case, what do you think? type 1 is worse, type 2 is worse, or they're equally bad? What do y'all think? Yeah, in this case, I think they're equal because the repercussions are the same. You lose the election. Okay, so I would say they're equally bad. So in this case, we're going to let the level of significance be 5%. So let me write that down. The letter we use for level of significance, it's a Greek letter, and it's alpha. And alpha is 5% or 0.05. Any questions so far? Okay, so the next thing I do is I need to decide what's called the p-value. I think I can draw a picture of that. Always a good thing to do. So pictures in this class are always the same from now on. We have, or just about, we have a normal curve. NP and NQ are definitely bigger than 5, 50% of 1,422 is 711, and that's much bigger than 5. And 1 minus 50% is still 50%. So there's no problem. We have a normal distribution. It's so much bigger than 5, it's almost exactly normal. It's really, really close. So what we can say is that if it was 50%, so let's draw that. So if it was 50%, 0.5, we just did our study and we said out of the 1422, we had 56%, and that's over here, which is 0.56. Our H1 is that it was greater than, so what we're going to look at is what's called the right-tailed. We're going to look at that area there. That area is how rare it would be to get 56% or higher if it had been 50% as the mean, okay, or the proportion, sorry. So in this case, we need to find that area. And if it's very rare to be that big, then we'll what's called reject the null hypothesis and say that H1 is true. If it's not that rare, then we're going to fail to reject the null hypothesis. We're not going to say H naught is true. We're just going to say we don't know. So the question I've got for you is, what does it mean to be very rare? Any thoughts? And the hint is, it's already up on the board. What does it mean to be very rare? And it doesn't mean your phone's going. Any thoughts? Yeah, less than alpha, in this case, less than 5%, because that's what we decided, that was our determination of when it's going to be too rare. So if it's very rare, then we're going to say that it's so rare, our assumption that p was 0.5 is just wrong, p is greater than 0.5. Whereas if it's not that rare, we're going to say, well, there's no reason to think that the assumption of p equals 0.5 is wrong. It could be right. Okay, so the next step we got to do is we need to find this, area. And you know how to use this using central limit and stuff, but we're going to skip to the chase. I'm going to jump right to the chase, and we're going to use the calculator's fancy function. So now let me reshare so you can see my calculator. Let me find it. Where is it? There we go. So here's the calculator. And what I'm going to do, we've seen this before, we're going to hit the stat button. The most important button in this class is stat, since this is statistics. I'm going to go to tests. This is not a confidence interval. This is not an int. This is a test. And in this case, which test is it, considering what the survey question was, which is, do you think climate change is an emergency? And the hint is it's on the screen. Okay, it's not a t-test because a t-test is for quantitative. Remember the same as the t-interval? That was for the quantitative question. But this is a yes-no question. Yeah, this is about proportions. So it's a one-prop z-test. One, because there was this one survey question and one population we're looking at. Prop for proportions because there's a yes or no question. Z because we decided our sample size is large enough. And test because we're doing a hypothesis test. So it's important that you can look at the calculator and see what each of those little pieces mean. Because on the final exam, you're going to be asked, and it could be any of these things. So you're going to be able to find the right one. That's going to be a hard part of the final, by the way. So I'm going to go down to one prop z-test. I'm going to hit enter. It asks for P naught. P naught is the P in H naught. So in our case, H naught was that P was 0.5, so I put 0.5. X was 56% of 1,422. And if you throw that in your calculator and round, and you should round to the nearest whole number, you get 796. And I noticed that there were a few of you that had issues because you weren't rounding. If you put in the 796.2 or whatever it was, it'll give you an error because you can't have 796.2 people say yes. So you do need to round, and you use rules of rounding for the rounding. Then we're going to go to N, and N is 1422. Any questions on that? Because that was our sample size. Then it asks for not equal to, less than, or greater than. Which one are we doing? Tina asked, how to get 796? I took 0.56 times 1,422. Because the article said 56% of the sample said that climate change was an emergency. So I took 56% of the sample size, and that gave me, round to the nearest whole number, 796. Okay, so which of these three? Is it not equal to, is it less than, or is it greater than P naught? Yeah, this one's greater than. We already decided that. That was in the H1. So I'm going to go and I'm going to scroll to greater than, hit enter. You know, I've never seen any use for choosing a color, so forget it. So a lot of the calculators don't have color, so don't worry about it. And then I just go to calculate, hit enter. And there we go. All right, I want to ask you something. Is the p-value 3.27? Okay, definitely not. And this is something important. The p-value, remember, is the probability of getting something there or greater, at 56% or greater than. It can't be 3.27 because that can't be a probability. You can't have a probability bigger than 1, remember? So yeah, so what we're missing is that E-6. That E-6 tells you need to move the decimal place over 6 digits to the right. So the p-value is going to have 5 zeros and then a 3. Okay, I'm going to write that down because we're going to go to the paint, go to the whiteboard, and then I need those numbers. So 0.00003. That's good enough. 1 decimal is plenty there. Z is 4.508. That's a z-score. Had the proportion been 0.5. And we could look at that. If you have a z-score of 4.5, what does that tell you? Yeah, it's a super outlier. Okay, I mean, it's ultra extreme. And we can see that with the p-value. Okay, so the test statistic in this case is z equals 4.5081457944. Okay, you can round however many it asks you to round. So that's the test statistic. The p-value is where it says p equals. The p-hat, that was our 56%. You can see that rounds to 56%. And the sample size is 1422. Okay, so now I'm going to unshare my desktop. And I want to go to, or change my desktop. I want to go to the whiteboard. And let's do that. Okay, so here's a whiteboard. Our p-value, let me just rewrite that because it's so important. P-value was equal to 0.000003. And the important thing is that is much less than 0.05, because that's what we're looking at. So we say we're in the rejection region. The shaded in region is the rejection region. Okay. Actually, the shaded in region from 0.05 is the rejection region, which is around here where it's 5%. So that means we reject the null hypothesis. So let me write down the conclusion. Reject H naught. So there is statistically significant. And actually, I'm going to write strong. Strong because it's not just less than 0.05, it is much less than 0.05. So it means I can brag a lot about it. Significant evidence to conclude that the majority, which means more than 50%, because that's what our H1 is, of Americans, and let me write down of all Americans, and all is important because we're talking about the entire population, not the sample. So if you don't have that word all, I will take off points, by the way. Okay, you need to specifically indicate you mean everybody in America, of all Americans. Think that climate change is an emergency. Any questions on the conclusion? Any questions? All right, I'm gonna, let's see. How would you say that the P was, okay, so if P was 0.04, you say it exactly the same except without the word strong. So you'd write down exactly the same words, but you wouldn't put the word strong, you just say there's statistically significant evidence. And if the p-value is 0.06, then you would replace the word strong with weak. So then you have weak evidence. It's not really significant, it's just weak, but it's better than nothing. If the p-value is, say, 0.4, you don't even go there. You just say we don't have any evidence. Okay, not 0.04, but literally 40%. If it was a huge p-value, bigger than 10%. That's kind of what you do if you don't have an alpha, is you have strong, you have weak, you have just statistically significant, and then just say, we don't have evidence. Any questions on that? But Tina, really good question. That's really important. All right, now I want to interpret the level of significance. Okay, and that gets a little tough, so bear with me. What we say is that if exactly 50% of Americans, let me write all Americans, think that climate change was an emergency, and if we surveyed another, was it 1,422, that was our sample size, Americans, then there would be A, and our p-value, our level of significance is 5%. So the 5% chance of falsely concluding it was greater than 50%. I know I'm running out of space here, sorry about that, of Americans. What if I can scroll down? Oh, good, I can scroll down. Think climate change is an emergency. So if the sample is like your other videos, then you would say something like percent of all first-year college students. Yeah, it depends on the example. So I'm giving you this example for now. You could look at my other examples and see others. But for this one, we're talking about climate change being an emergency. And what we would say, it's basically that there would be a 5% chance of a type 1 error. Okay, now, because I'm running out of space here, well, it looks like I can keep typing. Just scroll as I go. So now interpret the p-value. So p-value is a probability. So what's it the probability of? And the good thing is, let's see if it lets me do it, is I can take all the way up to here, I can copy it, and I can paste it in. It starts exactly the same. If exactly 50% of all Americans think that climate change was an emergency, and if we surveyed another 1,422 Americans, then there would be and now this is a very small chance. This is if we move the decimal over 2, 0.0003% chance. That at least, and we had 796 of them would say that climate change is an emergency. But you'll notice that it starts the same. It's like if H naught is true and we conducted another study with the same sample size, that's what this is. Then for the p-value is a chance of getting what you got or more extreme. And what we got was 796 said yes. More extreme would be more than that. Any questions at all about this example? Any questions? Okay, so I'm going to be erasing this because, whoops, interesting how it does things. There we go. I'm going to erase this because if I don't erase it, I have no space to do everything because I've kind of used everything already. So let me select. Let me delete. And I got to delete a little more. And I want to do another example. The other example, more of a stock answer, not as modern, but that's okay. So let me pop in another example. Okay, so here's the next example. The average American gets 4 hours of physical activity each week. A study was done to see if Tahoe residents, okay, because people in Tahoe, we might exercise more. If Tahoe residents are different from the rest of the US, okay, we might exercise less. But the question is, are we kind of unique or are we just like everyone else? Okay, the 45 Tahoe residents surveyed averaged 4.8 hours of physical activity each week and at a standard deviation of 2.1 hours. So what I want to do, you want to see the bottom? I think the bottom might be gone now. Sorry about that. But again, this is recorded, so you can always look at it again, Eileen. But if I don't continue, I won't be able to do a mean one. A quantitative study. So I do need to keep going. But if you ever have questions, please ask before I erase. Okay, so this one is different. And by the way, I didn't write this out because I can just say it, and that is perform the entire hypothesis test. So how is this different from the one I just did? What's the big difference between this one and the one we just did about thinking that climate change is an emergency? This one's got one big striking difference. Yeah, this one's quantitative. And by being quantitative, we have to answer things pretty differently. So the first thing is, I need to write down my null and alternative hypotheses. So now we have H naught colon, that's the same. Now what gets different? What letter do I use now for this one? Yeah, this one's going to be a mu, and it's a mu because the survey question is how many hours did you exercise this week? And the answer to the survey question might be, well, I exercised 6 hours. Okay, it's not yes, no, it's a quantitative study. Any questions on that? All right, and then always an equal when we have a hypothesis for the null hypothesis. And what number goes next? What comes after the equal sign? No, we're not ready for H1. It's not 4.8. It was a good try. 4. Because if Tahoe is just like everybody else, that means that our average should be 4. Any questions on that? Then, as Alex suggested, we're going to have an H1 and a colon. And we're still going to have a mu. What symbol comes next after the mu? This is another big difference between this one and the last one. Yeah, this time it's a not equal to. It's not a greater than. The key word here is a study was done if Tahoe residents are different. So the word different mathematically is a not equal to sign. It's very important you get that down or you'll get the p-value wrong when you go to your calculator. Any questions at all about that? And then still a 4. Any questions? Okay. In this one, I'm not going to get, again, we don't have so much time, so I'm not going to get into the type 1 and type 2 errors, but you can think about the type 1 error and the type 2 error. Type 1 error would mean, I'm not going to write it out, but I'll say it. It would mean that you have evidence, or you think you have evidence to say that Tahoe residents are different than the rest of America, but they're not. And what you do based on that, I'll let you think about that. Whereas a type 2 would mean that you don't have evidence to say that we're any different, but we are, Tahoe people are actually different. Okay, and I'll let you think about the issues that might come from that. All right, and let's say we might use alpha as 0.05 again. They might be similar, I don't know. So alpha is 0.05. So then what we need to do is we need to go and put in our calculator, and we need to get the p-value. So let's do that. And again, I always recommend that while I'm doing it in my calculator, you get your calculator out and make sure you're seeing the buttons on your calculator, because sometimes they're slightly different depending on the version of calculator you have. So I'm going to go to stat. Then I'm going to go to tests. What test now? The hint is it's not a one prop z-test. Any thoughts? So what test do you think it might be in the calculator this time? Not seeing y'all jump in, but let's see. Okay, z-test is a good idea, except it's a t-test. A z-test is when you know the population standard deviation, and we don't. We only know the sample standard deviation. And by the way, in the real world, you never know the population standard deviation. So on next week's midterm, I will not give you a problem that uses a z-test. If you use a z-test, I'm going to take off points. So that's just a big warning about next week. Because in the real world, you never do a z-test. But t-tests happen a lot. So it's a t-test. Any questions on that? All right. It gives you a choice between data and stats. Do we have data or do we have stats? What do we have with this problem? What do you think? I see both of you saying stats and data. Okay, this time, data would mean that we have all of the answers of the 45 residents. Do we know the answers of all 45 residents? We don't. And because we don't know the answers of all 45 residents, we don't have their data. We do have their statistics, though. We have their mean and we have their standard deviation. Those are statistics words. So I'm going to go over to stats and hit enter. So Kylie says it'll either be one prop z-test for proportion or a t-test for quantitative. So Kylie, that's true for chapter 9. Notice I said chapter 9, chapter 10, chapter 11, chapter 12, chapter 13. Those are all different tests. But since the midterm only goes through chapter 9, you're pretty good with that. Okay, unless it's a hypothesis, unless it's a confidence interval, and then it'll be a one prop z int or a t interval, because those are confidence interval pieces of the calculator. Because we had that in chapter 8. So hopefully that makes sense, Kelly. Okay, yeah. So for chapter 9. Okay, for the midterm. The homework, there might be one where you know the population standard deviation. I could throw that on homework, but I wouldn't throw it on a test. So now I'm going to go to mu naught. That is the mu in the H naught. And if you remember, that was 4. And then X bar, that was the mean for the sample, which is 4.8. And then we have SX, and SX is the standard deviation for the sample. That was 2.1. We had N, which was 45. We have mu, okay, not equal to. So I need to enter a not equal to, because that was in our hypothesis. Color I never care about. And then I hit enter. So our test statistic is 2.55556, and our p-value is 0.014. So what do you think? Is there statistically significant evidence? What do you guys think? Yeah, there's statistically significant evidence. We won't say it's strong evidence because it's not less than 0.01. So we don't use the word strong on this one. So there is statistically significant evidence. So let me go back to the board so I can type it out. So we can say there is statistically significant evidence to conclude that the population mean, got to have the word population, by the way, or I'll take off points. Population mean hours of physical activity for Tahoe residents is different from the average American. And note that was 4 hours. So it differs from 4 hours. Any questions? Any questions on the conclusion? This is the conclusion. If I ask you what you can conclude, this is how you write it. There is statistically significant. By the way, I don't know if I'll have time to do an example where it's the opposite. If our p-value is, say, 0.7, I would say there's statistically insignificant. So the opposite of significant is insignificant. Okay, so be real careful about that. You got to have those wording right. All right, I want to interpret the p-value because that one's particularly sometimes troublesome for some people. So let me go to a p-value. So interpret the p-value. And what we can say is that, again, you always start with if H naught is true. So if the population mean hours of physical activity that Tahoe residents get is 4 hours. And if another study of 45 residents was done, then there would be and our p-value was about 0.01, so 1% chance that either, and this is where it gets a little complicated, and this is why I want to make sure I interpret the p-value, either more than 4 either the sample mean would be greater than 4.8 hours, or the sample mean would be less than 3.2 hours of exercise. All right, I'm going to open this up because, again, this is subtle, a little difficult for some people. Where did I get 3.2? Yeah, Tina says, how do you get 3.2? Where did I get 3.2? And while you're thinking about it, I'm going to draw some pictures. Whenever I say draw a picture, you should all know what I'm about to draw. Okay, yeah, it's the extreme on the other side. So notice we have a normal distribution. The mean is 4. Our value that we got was 4.8. But if you notice, H naught was that mu is not equal to 4. It's not that mu equals 4. It's not that mu is greater than 4. So when you're looking at this is going to be what's called a two-tailed test. So that point 0.01 area is actually both sides because it's two-tailed because of the not equal to. So notice that 4.8 is 0.8 bigger. How to get 4 again? If you read the question, it says the average American gets 4 hours of physical activity. So there's a 4. Does that make sense, Alex? So that came from the question. So that was all Americans get 4. How about Tahoe? Okay. So now 4.8 is 0.8 bigger than 4. So the other side, if we reflect across that number 4, we have to go 0.8 less than 4. And that's 3.2. Because 4 minus 0.8 is 3.2. Any questions on how I got that 3.2? Okay, and you only do it this way. You only have to do both sides like that when you have a not equal to sign. If you had a greater than, you do right-hand side. If you have a less than, you do left-hand side. But with the not equal to, you have to do both sides. Any questions at all on this example before I start talking about the midterm? Okay, I'm going to say one more thing before I talk about the midterm, which is pretty important. Okay, so the area in the middle would be 0.99, yes. If there's 1% on the outsides, there's 99% on the inside. Okay, so that's definitely true. All right, so now what I want to do is I want to reshare my desktop to something different. Actually, it'll first look the same, but it'll be very different very soon. Okay, we're right now in week 7. And if you go to the assignment on week 7, on the discussion assignment, I want to note something that's really important. Okay, it says, please find an article that has been peer-reviewed and published in a journal. Do you know what that means? You know what it means to be peer-reviewed and published in a journal? It's scientific, so you're not going to go to, say, CNN.com or Gallup or Fox News. Those are not peer-reviewed and published in a journal. Okay, you need to go to a journal article. And I'm making you do this because this is college. And college students should know and understand what it means to read and see a peer-reviewed article. So one of the nice things is that our college, Lake Tahoe Community College, which whether you feel like it or not, you are a student of Lake Tahoe Community College. Even if you live in Korea, because I know we got one student in Korea, you're a Lake Tahoe Community College student, okay, by definition, because you're taking this class. That means you have the ability to go into what we've got here. And if you go to the menu, I believe it is, and you go to library, if you have a larger screen, it'll be towards the top instead of on the side, by the way. You go to library and you go to find articles. And you go to academic search complete. Okay, now I am at the college right now. If I was not at the college, if I was at home, it's going to ask me for my login information. That's your student ID and your first 2 letters of your last name. So you're going to have to type those in to get in. Then you're going to type in whatever you might be interested in. Let's say you're interested in finding out about, I don't know, how about baseball? Because, you know, we are in the middle of the World Series, and I think it's happening. I don't know if it started yet. Bruce, has it started yet? World Series today? Not sure. Las Vegas Fury likes baseball a lot. So World Series may have happened or not. I'm not sure. But I'm going to go baseball, and I can do a search. And I can limit to and this is what I want to do, scholarly journals, peer-reviewed. And there we go. The first one, baseball timeline, summarizing baseball plays into a static visualization. I'm not going to open it and read it, but this is how you can find whatever you're interested in. A good percentage of peer-reviewed journal articles have p-values. Just let you know that. Okay, so it's also easy to find p-values, but it's a requirement for this particular assignment, is you must find p-values. Okay, and you must use a peer-reviewed journal article. Okay, note if you give the link, if I click on that, don't do the link won't work. Instead, what you want to do is you want to copy the title of the article and paste it onto your post. And then everyone will be able to search for that article by its title, and they'll be able to find it. Permalink might work. That's possible. I haven't used that. I just do the title article. It's a lot easier. And then everyone can see what it's about. If it's just a link, it's hard to see what it is. If it's a title, it's pretty clear. Any questions on the discussion side? I want to make sure that you know what you're getting into. I mean, there's a lot more, but you'll notice then you got to reply and you got to do the full analysis like I did today. Okay, you write down the null hypothesis, the alternative hypothesis, p-value, level of significance, look at the conclusion, and you should be writing down the full conclusion. And I did notice it's pretty long what I typed out. Always look at what I typed in and use that as a model of what you should be posting on your particular reply. Okay, and mine was about Halloween because that's happening this week. Okay, any questions about the assignment before I move on to the midterm? Okay, if there's no assignment, no questions, I'm going to go to modules. And a couple things. The first thing is this week, in fact, tomorrow you must complete the midterm information quiz. And that basically says, where's your proctor? I need to know who to send your midterm to. If I don't know who to send your midterm, then you won't be able to take the midterm. So it'll look like this, actually. There's 4 questions, and I showed you last time, but make sure you do it by tomorrow. Those who did it by today before the webinar, I have sent the test out already. What I recommend is that after you've done it, after I've sent it out, then contact your proctor and make sure that they're ready for you. It's always a good idea. Make sure that everything worked. I emailed it especially, unfortunately, especially this week. I already got one email back from a proctor saying, I hope I can do it. Our electricity's out, and we'll see how it goes. Because California, I know not all of you are in California, but most of you are. California's got all kinds of problems right now with fire. So hopefully, let's cross our fingers that the fires will go out and the proctor centers will all be open and there won't be any issues. But you should definitely contact your proctor to make sure that they're ready for you before you come in and take the test. Any questions at all about the midterm information, what I call quiz? It's required, by the way. If you don't do it by tomorrow, you lose 5% immediately. And then if you wait later, you may not even be able to take the midterm because by the time your proctor gets it, they may not be ready for you. So tomorrow's the day. Okay, and if you did it early, great. I already sent out the midterms. They've got it. And in fact, let me go, in fact, I got to go back to Zoom because I want to show you what it looks like. So that's all part of what the midterm is going to be. Just a second. Or not Zoom, back to Paint. So I want to kill all this stuff. And I want to show you what I'm sending out because I think that helps you. Okay, at least part of what I'm sending out. Okay, so here's what happens when you send me your proctor information and I verify that the proctor is an official person, official proctor center. This is the email I send out. And let me read it. It says, Dear Proctor, thank you for the proctoring information. Here are the rules for the exam. And number 1, please check the student's ID to verify the student is indeed, and those X's are your name, by the way. So you have to show ID. It doesn't have to be your driver's license, but just a photo ID. It could be a student ID, and any student can get a photo ID. No matter where you live or what your documentation is, you can get a photo ID. It could be a passport, but you need to have a photo ID. Okay? Number 2, student may bring pencils, pens, any calculator, not a smartphone or computer with a calculator on it. A 3x5 note card with writing on both sides, and you can have blank scratch paper. So that's what you need to bring to this exam when you take it. Okay? And you might want to bring extra batteries in case your batteries die in your calculator. Always a good idea. And again, the 3x5 note card, make sure you put all the formulas you don't want to have to memorize. So things like the formula for the sample size for a confidence interval for a population mean. There's a lot of different formulas. For formula for a z-score, there's a bunch of formulas. Make sure those are on it. You might want to put some example problems. Whatever works for you, but you have 3" by 5" on both sides, and that's what you can put on it. Okay? The student may not bring a cell phone, smartwatch, notes other than what the student has put on the 3x5 note card, or any book. She, I gotta change that, it should be she or he, can leave her cell phone and her smartphone when she takes a test or he takes a test. Okay? Okay, so in other words, you're not allowed to use a computer or a smartphone, and emphasizing that. The student has 2 hours to complete the midterm. Okay, so give yourself 2 hours. Don't think you can do it in less time. This is a pretty long test. There's a lot of writing in it. Okay, after the student has completed the midterm, please scan it or take photos and email it to me or fax it. There's my fax number, et cetera, et cetera. Okay, so those are the rules of the exam. Are there any questions about the rules of your exam? Any questions? Okay, but I'd like to show this to you. And it's a good thing I read it because I accidentally put, I don't like to make it gender specific because I don't even know what gender you guys are. So sorry if I put she and you're a he or they or something like that. But that was my mistake. Okay, so other than that, it's going to say this. Okay, and of course the X's will be your name. All right, I want to go back and I want to show you some nice resources that you can use for studying. Is that the one? Wrong one, sorry. Let me share. Do it again. That one, there we go. Okay, so for studying, if you go to modules, I just showed you in the week 7 module, that was where you have to tell me who you're taking the test with. In the week 8 module, week 8 is when you take the test. It must be taken, by the way, by a week from tomorrow. And I put in some information, some things that will help you. I'm going to start out with probably the most useful for understanding what the midterm is going to be about. So let me go to Midterm Online Spring 19 Shell. What I did is I took your real midterm and I erased some pieces of information so that you have what's called a shell for the midterm. So you kind of get an idea of what the questions are going to be about, but not all the details. And this way, it'll help you study because you know what you've got coming at you. Okay, so let me start out with the instructions. Please work out all the given problems. Credit will be based on the work that is shown that contributes toward the final answer. So really important is show work, because if you get the wrong answer and you don't have your work shown, you get a 0. And if you get the right answer and you don't have your work shown, you're only going to get a small part of the grade. So you got to have your work shown for anything that has work. Okay? Problem number 1. Okay, for each part, write down the sampling distribution for each. Put in your normal curve diagram. Answer the question and determine whether the normality assumption was needed. Okay? Do you remember doing these problems? Doing something like that? Yeah, if you go to the webinar from 2 weeks ago, you'll see that I did an example where I talked about 4 things, and I even label it 1, 2, 3, and 4. The A, B just means there's going to be 2 questions, an A and a B. So you have to know how to do 2 different things. And then for each of those, there's 4. So there's a total of 8 things that you have to do on problem number 1. Okay. For the first, write down the sampling distribution. What does that look like? What does the sampling distribution look like? What might an answer look like? Okay, and it's not a probability, actually. It's a good try, though, Tina. Okay, the first thing is has a tilde in it. There we go. Kylie knows. So that might be x bar tilde n, and then the mean and the standard deviation. It might be x tilde n, the mean and standard deviation. It might be sigma x tilde n, the mean standard deviation. Okay, it could be x tilde u, except it probably isn't, because I wrote down about normality. So that's a hint. You should worry if you have a u on this one. That makes sense to you? Okay, so that's what part A looks like. Number 1 looks like. It's going to look like one of those. Don't forget about the formulas. And again, put it on your note card if you need to. If you're talking about an x bar, then the mu is the same as the mean. The mu sub x bar is the same as the mean, and the sigma sub x bar is sigma divided by the square root of n. If we're talking about a total, then the mean, the mu is the same. The mu sub sigma sub total is mu times n, and the sigma subtotal is sigma times the square root of n. So again, you can go back to the webinar a couple weeks ago. There's lots of examples, a long video's got it, but I've done that. Number 2, okay, is put your normal curve diagram. So your picture should have a normal curve on it. Okay, you should all know how to draw a normal curve. You should write down the center of that normal curve. And then you should write down shaded what you're interested in. If you're given a value of x or x bar and you want to find an area, then you have that x bar given and the area is a question mark. If you're given an area and you want to find an x bar or an x, then the area is not on the x-axis, it's above. And your question, your x or question mark, is going to be on the x-axis. So there's things to note. Okay, answer the question. That's going to take calculator work. That's probably going to be a normal CDF or an INV norm. Okay, and show what you put in your calculator, whether it's normal CDF or INV norm. Okay, and that way I can give you partial credit if you make a little mistake. Okay, and then determine whether the normality assumption was needed. Okay, if it's a yes/no question, then that's NP and NQ greater than 30. I mean, greater than 5. If it's a quantitative, it's N greater than 30. So those are the 4 things you're going to do. Any questions on that? Okay, question number 2. I'm going to give you a paragraph, and then I'm going to ask you to discuss the implications of a type 1 error and discuss the implications of a type 2 error. I did an example of that today. Okay, remember the exam's not for another week, so you have all week to do chapter 9. All right, question C, part C is do the hypothesis. State your conclusion. What words should you have when you're stating a conclusion? Okay, all is one. How should it start? Okay, definitely not if, Tina, but it's a good try, but not if. The if is not part of the conclusion. Any idea? The first word should be there. What's the next word? First word is there. And again, think about today. We did it today. I know it's been 15 minutes or 20 minutes ago. Okay, if you don't remember, there is statistically, and then it's going to be significant or insignificant. And you may have the word strong or weak before statistically. Does that make sense? That's the conclusion. The conclusion is not looking at the 0.05 or the p-value and interpreting that. That's different. That'll be a different question. All right, question 3. Circle true or false. And there's an A, B, C, D, E, F, G, and H. Just to let you know is that you get points for getting it right. You don't lose points for getting it wrong. You don't get, the worst that you could get is a 0. So you would be foolish not to put something in. Do not leave it blank. Because if you totally guess, if you have no idea what's the probability, since this is a stats class, of getting it right for any particular one of these. Yeah, 50%. Okay, if you leave it blank, what's the probability of getting it right? 0. So don't be dumb. I always have people leave them blank and I go, ah. So don't leave it blank, make sure, but hopefully you don't have to guess. Hopefully you have a good idea and you can write it out and you know whether it's true or false. All right, problem 4. I'm gonna tell you that it's a question from either chapter 4 or 5, but it's also gonna include concepts from chapter 3. There's a lot there, so I'm gonna let you study. Question 5 is a question from chapter 2. Question 6. Question 6 is a question from chapter 8. So determine a 95% confidence interval will be part A. There'll be a paragraph before. Write a sentence to explain your findings. What are the first words in part B on number 6? Okay, everyone will have exactly the same first words if you do it right. Any thoughts? I know it's been a week. No, definitely not if many samples. But it was a good try. Okay, maybe I should tell you. With 95% confidence. And then it can be concluded that. That's how you start. Any questions on that? For part C, use a sentence or two to explain what it means in the context of the study to be 95% confident. That, Tina, is where you start with if many samples. Any questions on that? For part D, we're talking about assumptions about the normal underlying distribution. That's how big the sample size is. Okay. Problem 7 is another confidence interval question. Okay, I'm not going to go into as many details on that, but it's another confidence interval. Question 8 is another one from this week. So a lot of this test is from this week, last week, and the week before, by the way. So write down the appropriate null and alternative hypothesis, find the test statistic, and the p-value for the study. Use a complete sentence to state the results. And now part C is you're supposed to interpret the p-value, and part D is you're supposed to interpret the level of significance. So again, that's what I did today. Question 9, I'm just telling you from chapter 1, 2, and 3. Question 10, you better all get this one right because it's extra credit. And you're just supposed to write down one thing that your instructor, that's me, could have done for you to help you better succeed in the online course. Part B is write down one thing that your instructor did for you that helped you succeed. C is write down one thing that you can do for yourself to help you better succeed in this online course. And D is write down one thing that you have already done for yourself to help you better succeed in the online course. So what went well, what didn't go well. And that's the test. Okay? And again, I literally grabbed the test and I erased what I felt like I should erase. Okay? And I added things like question from 1, 2, and 3 instead of erasing everything and leaving it blank. So any questions so far before I move into a couple strategies? All right, so now if I go back to modules, there's a lot of things you can do to study. One main thing that I recommend doing is going back to the discussion posts. So for example, even this week, and you go to the discussion post, read my model, because that has the words that I'm expecting. Okay, there's this week, every week I have a model of something, and those are kind of highlights. So that helps. Read it and then practice writing your own. Okay, you can do that from the homework, and that'll help you practice. Okay, then other things you can do. One thing you can do is, let me go back to modules. Under, I believe, course information, you see review applets? We're there now. Okay, yeah, you're not gonna be able to fit everything on a 3x5, so you're gonna have to decide what to put on. Okay. So if you go to review applets, click that, and you will see practice true-false questions, because remember, there's a true-false question, whole set of them. You want to click descriptive statistics, probability, confidence intervals, and hypothesis testing. Okay, when you're studying for the final, you'll click the rest, but not now. Then you're gonna hit submit, and this will give you a lot of practice true-false questions. Any questions on that? And this should work on, it should work on your smartphone because I did it in JavaScript. I coded this. All right, more things you can use. Go back to modules. And you go to week 8. There is, I believe I have more stuff. Where is it? I think that's about it for those. But what you can do is you can go to any of these homeworks. So for example, here it is. No, not midterm information, this one. You can go in here and let me show you what I recommend doing. What I recommend doing is reading this paragraph and then answer it like the midterm. Don't read this with all these multiple choice things because you're not going to have multiple choice stuff. You're going to have to actually write it out. So read the question, then write out the full solution. Okay, and that's a really good way of studying. Okay, for each of the chapters, especially chapters chapters 7, 8, and 9, because that's a big part of this test. Because you already kind of had the online midterm before. So I put more from later stuff. And later stuff's more important anyway. But there's also other chapters that you should look at too. Something I don't want to forget. So let me go to one more thing. Very important. The secret word for today is level. Is level, because you have a level of significance. I always try and pick a word from the topic that you probably wouldn't just guess. So that's the secret word of the day. All right, so at this point, I will be happy to take any questions you might have. And hopefully this midterm goes well for you. Next week, I wanted to ask you something. Any of you, at least those who are here, are going to take the midterm Wednesday and not finish by 6:00 p.m. Because I looked at it, in fact, I got my list. I didn't ask for the time, but I realized there's actually, I only see 3 people have already talked about it that are taking Wednesday. And if you're taking it So most of you are finished. What I'm thinking about is waiting on, take it at 4, so you'll be done just at 6. Okay, you might be tired, Alex, but that's okay. What I'm thinking about is for next week's webinar, since I'm talking about stuff that isn't on the midterm, I'm talking about chapter 10, and I'm talking about the project. I'm thinking about having it on Wednesday, a little later, because I want you to focus on the midterm for up to Wednesday. Sound good? That'll probably be the only webinar that's Wednesday. And that's because, again, it's post-midterm information. So that'll probably happen unless I hear otherwise from anybody. But that's when I'll probably have it. I know we've never had a Wednesday webinar because I usually have it on Monday or Tuesday. But I want you to be focusing on the studying for the midterm. Any questions at all? We're about out of time. It's 7:26. It's one of the later webinars. Always trying to end by 7:30. But that doesn't mean I'll end answering questions. It just means that I'll end the new material on the webinar. So any questions at all? And I'm always happy to answer questions if you have any. It could be about the midterm, it could be about hypothesis testing, it could be about your proctor, whatever you're going to ask. Hopefully the fires will be all out, because I know some of you are affected by that, and I'm sorry about that. The good news is Tahoe is supposed to be 5 degrees tomorrow morning. And the good thing about 5 degrees Fahrenheit is fires don't really happen. It's too cold for even a fire. But the bad news is down where you might be, it's dangerous. So any questions at all? As I've always say, I'm happy to take questions, or you can say goodnight too. And I'll be happy to look at the Q&A forums. And I'll be checking that often. All right, have a good night, Kylie. Was it one prop Z or T test for calculating the p-value? It's one prop Z test. There is no one prop T test, by the way. So that doesn't even exist on the calculator. And you use that when it is, again, one survey question, which is all we've got this week, and when you have a yes-no survey question, and when you're doing a hypothesis test rather than a confidence interval. And then it's going to be one prop Z test. So hopefully that answers your question, Tina. Okay. And yeah, that'll always give you the p-value, and it'll give you the test statistic. It'll be Z in that case. Does that make sense, Tina? Yeah, so it'll give you the p-value and test statistic. What are you confused about? So when you go to the calculator, it says Z equals, and it gives you a number. That's the test statistic. Huh?
I understand how to use a calculator. What I'm confused about, though, is interpreting, because if it gives me the statistic, and we're comparing the statistic and the p-value to determine the significance.
You're determining whether to reject the null hypothesis or not.
Right.
Whether it's statistically significant. Mm-hmm.
Right.
You look at the p-value, which
but if I use the same one, oh, that gives me both the p-value and. I'm still lost.
Okay, maybe I should show the calculator because I have it. It's still there. All right, you can see the calculator?
Yeah.
So in this example, the test statistic was 2.5555. Notice that's an outlier, so you can guess it might be statistically significant, right? And the p-value is 0.01.
Okay. So the significance is yeah, is the 2.555.
No, that's the test statistic. The level of significance is your alpha. That's like your 0.05.
Because we're okay, so like when we talked about that, we talked about the 0.0 or the 0.01, the 0.05, and the 0.1.
Right.
So the the 0.05 is when it's really doesn't really make a difference whether the error isn't going to have the type 1 or type 2 error isn't going to have that big of a right.
Well, it's not that big. It says they're about they could both be horrible, but if they're equally horrible,
Okay.
you see? Whereas
So
if the
one's
type,
not significantly worse than the other. And if the type 1 is, that's right, I wrote that down. If the type 1
yeah,
is significantly worse, then you're going to use the 1%. If
right,
the,
because you want a much smaller percent chance of a type 1 error. You see?
okay. And
Because
if
the level of significance is the probability of a type 1 error.
okay.
So if type 2 error is much worse, then you actually will make it higher, 0.1 instead of 0.05 or 0.01, because that, yes, the type 1 error is higher, but the type 1 error has a higher chance, the type 2 error has a lower chance, because it's a give and take.
Right, they're opposites.
Yeah.
Okay. That makes sense.
Okay, good.
It's because I wrote down all the numbers on the video, and you gave us more numbers on the in here. So I started putting in like instead of 1, 2, 3, 1, 2, 2.5. Your long video.
The long video, uh-huh.
Your long video, I only had written down 6 steps. But by the time when you finish this video or this discussion, I got like 8 steps.
Okay, yeah, this is a lot of things to do, and whether you call one of them 1 step or 2 steps, that's, but the order is important.
Yeah, so I inserted some things.
Yeah, the order at which you do things is important. Like you never decide on HA after you've done your data collection. That's really important.
That's huge, I would think, because then you could be your hypothesis could be skewed by results, causing you to change what your original thoughts were.
Right, and you don't want that to happen.
Mm-mm.
Any other questions?
I'm good. Thank you very much.
All right. Well, then have a good night. And for all of you who are watching this as an archive webinar on YouTube, have a great night. And I hope the midterm goes well. If you haven't already submitted your midterm information quiz, you need to do that by tomorrow. It's not an option. I put in several announcements, and you can't wait till weekends like other things you wait till weekend. This one's a biggie if you're late. It's ugly. So make sure that you submit that midterm information by tomorrow. And then I'll get that midterm out as soon as that's submitted, basically. Definitely by Thursday, but I'll be sending out tomorrow, and I'll be sending out more Thursday morning. So until next week, which will almost certainly be Wednesday, have a great one.